Good morning, students. Today we'll see some Boolean expression, and that given Boolean expression you have to convert or implement with NAND and NOR gate, right? So what is the logic for NAND and NOR? If given equation you have to implement with NAND, then in your equation there will be only dots and complements, right? And if given equation you want to implement with NOR, then your equation will contain only plus and bar. So this logic you have to remember, right? Now if you want to implement your equation with NAND or NOR, you have to apply De Morgan's theorem, that is A dot B whole bar is equals to A bar plus B bar, and A plus B whole bar is equals to A bar dot B bar, right? So these are the De Morgan's theorem. Yesterday we have seen this two De Morgan's theorem, and by applying this De Morgan's theorem we have implemented some Boolean equation. We have solved Boolean equations, right? So all of you know how to convert dot into plus or plus into dot, right? And today also we'll see how to implement the equations with a NAND and NOR. So De Morgan's theorem are nothing but the NAND and NOR logic, right? Here NAND function is there, and it is converted into NOR function. Here NOR is given and it is converted into NAND. So this is also called as a NAND NOR logic, right? Now we'll see some example with implementation using NAND gate and NOR gate, right? So equation is or question is given like this: realize following equation using NAND gate only, or implement following equation using NAND gate. Means the given equation contains only dot and complement, like this. So y is equals to AB plus B into C bracket multiplied by variable C. So in this equation plus is there. So if you want to implement with NAND, this plus should not be there in your equation, right? So you have to remove this plus. And how to remove this plus? By applying De Morgan's theorem, right? Now first we'll do the bracket multiplication. That means we'll multiply these terms, these variables with C. So it will like A, B, C plus BC into C. Now C into C is equals to C. So B into C will remain. Now in this equation, B into C common variables. So in bracket A plus 1 will remain, and A plus 1 is equals to 1. So answer is B into C. Now this equation you have to multiply with NAND. So put double inversion, right? Now double inversion means logically it will get eliminate according to inversion law, right? Now you have to draw the logical diagram for this. If you take one NAND gate and you will give B and C input to it, it will produce B into C bar. But here we want double inversion, that's why we will use a NAND inverter here, which will give you B into C double bar, right? And B into C double bar will get eliminated by inversion law. So putting double inversion bar here or not putting, the meaning is same. That's why we have taken double inversion bar. So what is the logic? Hope you are getting the logic, right? Now next equation is y is equals to A plus B in another bracket A bar plus C. So implement given equation using NOR gate. So implement given equation using NOR gate means the equation contains only plus and complements, but here multiplication is there. So you have to eliminate this multiplication. So how to do it? Write the equation as it is and put double bar or double complement on its head. Right? And after that, try to break this bar. So if you break this bar, this multiplication sign will get converted into plus. Right? So putting double inversion bar is doesn't matter, because by inversion law it will get eliminated. So you can use double bar anywhere. Right? So why we have taken this double bar? We want to separate. If we separate this bar, this multiplication sign will convert it into plus. And why we are doing this? Because we require our equation with NOR signs only. NOR signs means only plus and complements, right? Like this. So what we have done? We have given double bar. Now we are going to separate this bar. So if we separate this bar, it will look like now. If we observe this equation, it will contain only plus and complements. That means this is converted into NOR logic. Now if you want to draw a logical diagram for this, so for this, take NOR gate, give inputs A and B, it will give you A plus B bar. Right? So this term we have designed. For this term, A bar C means A requires inverter, but you have to use only NOR inverter. Right? So only NOR inverter will give you A bar. We have taken input from this. This is a NOR inverter, so it will produce A bar. C variable does not require any complement, so I will take C as it is and will combine with using NOR only. So this NOR will give you A bar plus C whole bar. Right? Here one bar is remaining. Sorry. So this term we have designed. Now again combine these two terms with NOR only. So NOR will take this input, this NOR will add these two inputs with complement. So A plus B bar plus A bar C whole bar, and this inverter will give again 1 bar. So this is implementation of given equation using NOR gate. So what we have to do, every time we have to put a double bar on equation's head. This will help you to convert a given equation into NOR logic or Nand logic by using De Morgan's theorem logic. Right? Now we'll see next example. Y is equals to A plus B bar C plus AC. Right? So we have to implement this given equation using NOR logic. So I will take these two terms together. You can change variables order by using commutative law or distributive law. Now in this equation, A is common, A variable is common, so in bracket 1 plus C will remain. So 1 plus C is equals to 1. So this equation will convert it into like this. Right? Now for NOR, you have to put double bar here. Right? This double bar means you are converting given equation in the form of NOR. Only plus is not required, complement is also required in NOR, right? So if you want to design this equation, then take B bar with NOR inverter. So this is B, this will give you B bar. Take this C as it is, combine with NOR. This will give you B bar plus C whole bar. Means here also you want plus sign. Means further implementation is also required. So here what we'll do, we'll apply De Morgan's theorem, we'll split this bar. So this will give me plus here. So how to do it? We'll write this equation once again. Our equation is like this: A plus B bar C double bar we have taken. So we want to remove this. So we'll separate out this lower complement. So this will like A bar. If we split, now again separate out this bar. This will give you B double bar C bar. Remove this double bar with inversion law. Now if you want to implement this with NOR, this multiplication you have to remove. So separate this bar. Right. So this double bar will get cancelled. Here put double bar, that means you can eliminate this double bar by inversion law. Now the whole equation is in the form of NOR. Only plus and complements are there. Right. Now take C bar with inverter. This B as it is. So if you combine with NOR gate, it will give you B plus C bar whole bar. That means this term, this A is as it is. Now combine this with NOR only. And again, if you put one inverter there, here A, this will give you this whole term, and this inverter will give you double bar, right? So like this you have to implement the given equation using De Morgan's theorem. Now we'll see next equation: A B bar C plus AC plus B bar C. Now this given equation you have to implement with NAND एंड नॉर. दोनों गेट को लेके इम्प्लीमेंट करना है. सो पहले हम इम्प्लीमेंट करेंगे नैंड के लिए. सो इफ़ यू वांट टू इम्प्लीमेंट द गिवन इक्वेशन विथ नैंड यू रिक्वायर ओनली मल्टीप्लिकेशन एंड कॉम्प्लीमेंट्स, राइट? मीन्स यू हैव टू रिमूव दिस प्लस. सो व्हाट विल डू, विल पुट डबल बार on given equation, right? And we try to separate this bar first. So if we separate this bar, the equation is like the whole bar is get separated, the plus will converted into dot. Wait a minute, sorry for interruption. So we want to separate out this complement. So this complement means this bar will goes each variable, each term, and this plus will get converted into dot. and this ऊपर वाला bar will remain as it is. Now see the equation, it contains only dots and complement. That means the equation is converted into NAND. Now the given equation we have to convert it into NOR, right? So for NOR you can take this equation once again, put a double bar, same equation, right? Now if we want to implement the given equation with NOR, this multiplication term will not be present there. So if we separate these bars, will get converted into addition, right? So for this term a bar plus b double bar plus c bar, right? So we have separated this, and this dots it converted into c, right? Now we'll separate out this a bar plus c bar, and for this b double bar plus c bar. ऊपर वाला bar will remain as it is. Now we have to convert these dots into plus, so we'll separate this bar. A bar double bar will get cancelled, plus bar so now you can see the whole equation is converted into NOR. There is only plus and complement. You have to put this double bar once again. The meaning is same only. So this is, we can say that implementation using NOR. The whole equation contains only addition and complement. In above equation, the whole equation contains only dots and complement. So this is called implementation using NAND and NOR. Now we'll see next example. Y is equals to a b bar plus a bar c plus a b c. So this given equation implement using with NAND only. Now this equation contains plus. So what is the first step? Put a double bar on given equation, and separate with this, right? So it will like a b bar bar into a bar c bar into a b c bar, and ऊपर वाला bar will as it is. So whole equation is converted into now dots and complement. So this is called as a implementation using NAND. Now you can draw this logical diagram for this, right? So how to draw it? For this term, this complement term, take NAND inverter, right? And remaining term take as it is. So how to draw a b bar? Take a as it is. B for b bar take a NAND inverter only, because we are implementing with NAND. So this is a, this is b, again combine with NAND only. So this will give you a b bar whole bar, right? That means we have designed for this term. Now second term is a bar c, right? So you will require a bar. So that means you require NAND inverter. So take a from this given to NAND inverter. So this will give you a bar, and the second variable is c, which is without complement. So take it as it is and combine this with NAND, which will give you a bars into c whole bar. That means we have designed second term. Now third term is a b c bar. So take a from this, take b from here, take c from here and combine with Nand, which will give you a b c whole bar. Now all this term you have to combine with Nand only, which will give you this 3 terms multiplication with bar, right? And again this is called as a implementation using NAND gate. So this is called as implementation using NAND. Now we'll see next example. Y is equals to a plus b, a bar plus c. Now this equation, given equation, you have to implement with NOR. Means you require only plus and complements, but here dot is present. So give double bar. First separate out this bar. It will convert the equation like this. Now whole equation is converted into plus and complements. Now you have to draw a logical circuit for this. For this term, take a and b inputs, give it to NOR. It will give you a plus b bar. So we have designed this whole term with bar. Now you require a bar c. So for a bar, take NOR inverter, which will give you a bar. Take c as it is. So combine with NOR, it will give you a bar plus c whole bar. And these two again combine with NOR. So this will give you a plus b bar plus a bar c bar whole bar. Sorry. So this is the implementation using NOR. We'll see next. Y is equals to ab plus a bar b. Implement, or the question is like draw logical diagram for this. So how to draw logical diagram for this? For a and b multiplication will take AND gate. So it will give a into b. Now here a bar, so take inverter, which will give you a bar. Take this b as it is. Here also NAND gate, a bar b, and here addition is given, so you have to combine this with OR. This will give you ab plus a bar b. So this question, for this question, draw logical diagram only, that much is given. No need to implement with NAND and NOR. Right? Practice these equations. Now we'll see next equation. Y is equals to a plus b, a bar plus c, and implement the given equation using NAND gates. Means it contains only dots and bars. So a plus b, a bar c, double bar, separate this bar, a plus b bar plus a bar c bar अभी इसको सेपरेट करना है. So it will like a bar into b bar plus a double bar into c bar. अभी ये प्लस हटाना है तो इसको सेपरेट करेंगे. So A bar into B bar bar dot A double bar जाएगा C bar bar. So whole equation is now converted into NAND. So if we want to draw the logical diagram, take NAND inverter for these two. Why NAND inverter? Because we want A bar and B bar. So here you will get A bar. If you use second inverter, it will give you B bar. Combine these two with NAND only, which will give you A bar dot B bar whole bar. For this, take A as it is. It requires C. So for C, again use another inverter C bar. Here A. Combine this with 2 A C bar whole bar. Again combine these two with one NAND, which will give you A bar dot B bar whole bar dot A C bar bar 1 bar, right? So here bar is not required. So if you connect one inverter, it will give double bar and this double bar will get cancelled. So this is called as implementation using NAND. So these equations look like difficult, but once you understood the logic, how to apply De Morgan's theorem, so it will very easy. But what is the important? You have to take care all the complements, small complements as well as big complements. While solving this equation using De Morgan's theorem, you have to take care all the complements, because so many complements or bars converted in equation while solving this. So don't miss any complement or any bar while solving. Keep see carefully which bar we are going to separate, how this bar will separate, how it will goes on which term, which variable. It will already contain some bars, so by inversion law try to remove it. So once you got the logic how to apply De Morgan's theorem, it will be very easy to convert any equation into NAND or NOR logic. So practice these equations, watch the video again and again carefully, then and then only you come to know how to apply this. So watching lectures regularly is very important. If you doesn't understood anything, you have to watch the video again and again, and if again you will face any difficulty, you can come to college, so I will help you. Thank you.